So the second reaction type that we'll go over here is single replacement, and this is from the note sheet that you already have, so you'll definitely want to get that out. Single replacement just means a free element and a compound come together to form a new compound and new free element. So the general formula is B plus AX yields BX plus A. So what does that mean? Well, I'll go over an example of the first type here. If the free element can form a cation, it replaces the cation in the original compound. So for example, if I have lithium reacting with, let's say, sodium, sodium oxide. So the reason that this is the first example, if the free element can form a cation, is because lithium is a metal. So metals, of course, form cations. They form positive ions. Right now, lithium is not a cation; it's just an atom. But it will, when it forms compounds, it will form cations. So it's going to replace the cation in the original compound, meaning sodium. So lithium replaces sodium, and so then you can imagine what you would get. You would get lithium now paired with oxide, and of course, because oxide is -2 and lithium is +1, the subscript on lithium would be 2, so Li2O, and that means sodium is off by itself. So we get this Na over here. And then, of course, we balance. So lithium has 2 on the right, so I'm going to put a 2 out in front on the left. Sodium has 2 on the left, so I'm going to put a 2 out in front on the right. And then when I'm done, I don't really need my charges to be written there, so go ahead and erase those. Now, there is a possibility that this reaction doesn't happen at all, meaning it's a no reaction. It says under note, the free element on the reactant side must be more active than the element it's replacing. So this is where we're going to use one of the items that's in the back of your green periodic table, and that is the activity series. It's also on the back of this note sheet. The activity series just tells you which element is more active. In this case, we're talking about lithium and sodium are the two that are going to trade places. Lithium, in my example here, is trying to replace sodium. So the question is, can it do that? And if lithium is higher on the list, and actually lithium happens to be the highest one on the list, it's the most active metal, so that means it can replace anything below it. Lithium can replace any other metal in one of these single replacement reactions. So yes, this is going to be a reaction. If I try to go in a different way, let's try, let's say I had aluminum, and let's go with, let's say it's going to try to replace potassium. So we have Al plus KCl. So I could kind of predict what the products would be here, but there may not be any point to it. I know that aluminum is a metal, so it's going to try to replace the metal in the compound, which would be potassium. So then I'm going to look at my list and go, oh, wait a minute. Let me erase my previous highlights here. So this time aluminum is trying to replace potassium, but aluminum is below potassium, so we cannot have aluminum replace anything above it. So this reaction doesn't happen, and you literally are just going to write no reaction or NR. Okay. Now the other thing that can happen is we can have an anion, and this is only going to work with halogens. So if you look at your periodic table, the halogens are going to go F, Cl, Br, and I. Like that's the order that they're listed in the periodic table, with F at the top of group 17. And so what happens there is we use the periodic table as the activity series. So for example, let's say I had F2 plus, let's go with calcium chloride. So this time it's fluorine that's by itself rather than a metal, as was the case in our previous two examples. So the fluorine's by itself, so it's trying to replace the halogen or the nonmetal or the anion, any way you want to say it, in the compound. And so the question is, can it do that? And just like with the metals, we're going to be looking at the activity series, but this time we don't have a separate activity series. We don't have a dedicated activity series for the halogens because the periodic table tells us this. So fluorine is above chlorine. So fluorine will replace chlorine, and so this is a reaction that will happen. And so we'll get calcium fluoride, which would be CaF2, plus chlorine, which is diatomic. It's one of our Brinkelhoff elements, so it's going to be a 2. And then we have to balance, although it looks like this one is already balanced. And then, so you're not going to have to worry about any anions being replaced that are not halogens. So that's why we say when it comes to anions being replaced in one of these single replacement reactions, you just need a periodic table, and you can just use the order of the halogens in the periodic table.